This is your last series of notes over speed, velocity, and acceleration. This one's focusing in on acceleration. So, acceleration, the definition of acceleration is the rate, velocity changes. So the rate velocity changes. Typical units for acceleration are meters per second per second. Physicists usually rewrite this to be written this way: meters per second squared. Means the exact same thing. Now, if you think about the definition of velocity, there are actually three ways that you can change your acceleration. One way is you just simply speed up. That's the way most of us are used to thinking about acceleration. Speed up. And we actually call that positive acceleration. There's two more ways to accelerate. One is slowing down. And you probably guessed that that's called negative acceleration. And the last way, can you think of it? It's any way that velocity would change. Anytime velocity changes, you accelerate. So the other way is actually changing direction. So when you round a corner, even if you don't slow down to go around the corner, you're actually changing your velocity because you're changing your direction. The formula to calculate acceleration is equal to velocity final, that means your ending velocity, minus your initial or starting velocity divided by the time it takes to change velocity. I will just write this delta, that means change, so the time it takes to change your velocity, we would just write that delta t. And that's the formula to calculate it. So this is just a YouTube link for one of the Eureka, what I call the hippie films. If you don't want to type that whole URL in, I bet you could go to YouTube and type Eureka #5 acceleration, and I believe there's two parts of acceleration on the hippie films. There's a part 1 and part 2. You want to watch the part 2 version. Well, this is a visual way to visually understand what acceleration is. If we start out not moving and we accelerate at a rate of 1 meter per second every second, what does that look like on a distance line? Well, when you start out, you would have times 0. So I'm going to write a 0 here. 0 seconds have passed. Now, if you're accelerating at a rate of 1 meter per second squared, what that means is in the first second, you will travel 1 meter. So after 1 second, you would be right there. Well, where would you be at 2 seconds? Well, you would actually end up being right here. How's that work? Well, in the first second, you went a meter. In the second second, you go the distance of a meter again, but you would travel 1 additional meter. So in the second second, you actually traveled 2 meters. Then, in the third second, you would actually be right here. Traveled the meter in the first second, 2 meters in the second second, 3 meters in the third second. Why 3 meters? Because in the previous second you had gone 2 meters, but you have to add an additional distance of a meter in your third second, so you actually travel 3 meters in that second. Now, where would I be after 4 seconds? 1, 2, 3, 4. I would be right here. 4 seconds. I had to go 1 additional meter. And then again, I would go 1, 2, 3, 4, 5. I would be right here after 5 seconds. And finally, 1, 2, 3, 4, 5, 6. I would be here after 6 seconds. Now, what about traveling at a rate of, or accelerating a rate of 2 meters per second? Well, if I start standing still again, I would be at the beginning at 0 seconds. Where would I be after 2 seconds, or after the first second? Well, I would travel a distance of 2 meters. So I would be right here, 1 second, sorry about that. So after 1 second, I would have traveled 2 meters. Well, I need to go 2 additional meters than I did the previous second. So I would go the 2 meters I had gone in the previous second plus 2 additional meters. So I would actually be right here after 2 seconds. At 3 seconds, I went 4 meters in the previous second. So I'm going to go 1, 2, 3, 4, but I have to go 2 additional. So 1, 2. I'd be here after 3 seconds. Here I went 1, 2, 3, 4, 5. Oh, I didn't mess up. 1, 2, 3, 4, 5, 6. No, I did it right. 6 total meters here. That's 6 meters that I went the previous second. I need to add 2 more to that, so I need to travel 8 in the next second. 1, 2, 3, 4, 5, 6, 7, 8. Here's where I would be after 4 seconds. This one's going by 1.5, so I'm going to put half tick marks in all of these, just so it's a little easier to tell what's going on. You could do that on yours at home too. And we'll get you started here. So in the first one, again, you'd go 0 seconds, you'd be at the start. Well, after a second, you would go 1.5 meters. Okay, so here's a half, here's 1, there's 1.5, so I'd be right there. So right here after 1 second. Well, I need to go 1.5 plus another 1.5, so that's 3. So I need to go 3 meters in the next second. So this would be 1, 2, 3. I'd be right here after 2 seconds. Well, I just went 3 meters, so I needed to go 3 more. So I'll count 3 first. 1, 2, 3, plus another 1.5. So here is 1.5. I'd be right there after 3 seconds. So then I need another, so I just went 4.5 there, so I'm going to go 4.5 plus another 1.5, which is equal to 6. So here's 1, 2, 3, 4, 5, 6. There's where I would be after 4 seconds. Alright, how about if I just accelerate at 0.5 meter per second squared? I'm going to let you do that one on your own. You can always come see me at school if you had a hard time with it. Alright, and to wrap things up, we're going to do a few acceleration problems. The formula again from the last page is acceleration is equal to your final velocity minus your initial velocity divided by the time it takes to change velocity. So we'll do problem A first here. It says after 5 seconds you've reached a velocity of 10 meters per second. What is your acceleration? Well, we're trying to figure out our acceleration, so we don't know what that is. Final velocity says after 5 seconds you've reached 10 meters per second. So our final velocity is 10 meters per second. Initial velocity is 0 if it's not stated. So we weren't moving anywhere to begin with, 0 meters per second, and it took us, I think that was 5 seconds. 5 seconds to do so. So then we just use that information to solve the problem. Acceleration is equal to final velocity, which is 10 meters per second. Don't forget to keep track of units like I'm doing here. Minus the initial velocity of 0 meters per second. Parentheses around that because you have to solve that first. Divided by delta t, which was 5 seconds. Then you solve the top part of the equation first, 10 minus 0, is equal to 10. And when you subtract units, you can only subtract them if they're the same units, and they are, so we just keep them, meters per second, divided by 5 seconds is equal to 2 meters per second. Well, what are the whole units here? It's meters per second divided by seconds, as you can see right there. So meters per second, and you can choose to rewrite that as 2 meters per second squared. It means the same thing. So that means you're accelerating at 2 meters per second squared, or every second that goes by, you go 2 meters further than you did the previous second. Okay, now we're going to solve B. It says you enter the freeway going 20 meters per second. After 10 seconds on the freeway, you reach a speed of 80 meters per second. What's your acceleration? So, let's list our variables. We don't know our acceleration. That's what the question asked. Final velocity. It says you enter the freeway going 20, but you reach a speed of 80. So final velocity is equal to 80 meters per second. And initial velocity, you're already moving, but you're only going 20 meters per second. And it says it took 10 seconds to do this. So now we can use the formula again to calculate our acceleration. So acceleration is equal to 80 meters per second minus 20 meters per second divided by the time it took to change from 20 to 80, which was 10 seconds, which is equal to, we now take 80 minus 20, we get 60 meters per second, divided by 10 seconds, which is equal to 6 meters per second every second, which we can write as 6 meters per second squared. And that would be the acceleration. The last problem I'm going to let you solve yourself, but let me give you a couple hints. You're in an airplane coming in for a landing, which means you're going to be slowing down, which, as you've learned in class, is negative acceleration. So I'm talking about C right now. So if you do everything right on this problem, you're going to get a negative number for a final answer. So set it up, solve it. If you don't get a negative number for an answer, or you're having a hard time, come talk to me and be glad to help you with that. Thanks for watching the notes on acceleration. Alright, I thought I was done, but one more slide here. We practice these in class too. You're supposed to classify these whether you think they are positive acceleration, negative acceleration, a change in direction only, or no acceleration at all. So what you should probably do is pause the video, see if you can do it, and then I'll go over the answers. Okay, plane taking off, you have to get faster and faster to do that, so that's positive acceleration. Car stopping, getting slower and slower, that's negative acceleration. Jogging on a winding trail, well, it's not positive or negative if you're not speeding up or slowing down. It could still be a change in velocity though, because you're switching directions. So even though it's not positive or negative acceleration, it still is acceleration, just changing direction. Same thing with driving around a corner, as long as you're not speeding up or slowing down. If you slow down to go around the corner, that would be negative acceleration. Showing a distance line what accelerating at 3 meters per second looks like. And I've done that previously in the notes, so I don't think I'm going to spend the time to go over it again. Alright, really, thanks for watching now.